and welcome. You should be on page 9 of your Algebra 1 Quarter 3 notebook. In this video, we're going to talk about exponent rules involving quotients. So let's take a look at the two last properties we're going to discuss with our exponents. The first is the quotient of powers property. Here's just a lot of words. Let a be a non-zero real number and let m and n be positive integers so that m is greater than n. But let's give that some algebra. So let A be our base. It's a positive non-zero real number. And M, the exponent, are positive integers so that, I'm going to put an A here, M is greater than N. If that is the case, if I have the same base in a quotient, that equals A to the M minus N. Alternatively, and I like to think of it both ways, because my goal is to not have negative exponents. What if I had A and my smaller exponent was in the numerator? That would actually equal 1 over A to the M minus N. So I can subtract and bring my exponents down to the denominator, or essentially up into the numerator. Let's look at that in numbers. In this case, I have same base. M is greater than N. 7 is greater than 2. So this will equal 4 to the 7 minus 2, which equals 4 to the power of 5. If I put that in the calculator, I get 1024. I could alternatively think of it this way. What if I had 4 squared over 4 to the power of 7? That would actually equal 1 over 4 to the 7 minus 2, same base, which equals 1 over 4 to the 5th, and that equals 1 over 1024. So I can move my exponent numerator or the denominator. Just like with multiplication, if I have a quotient in parentheses, the exponent outside will be distributed to the numerator and the denominator. So A and B are real numbers. B cannot equal 0, and why that is, if you remember anything about fractions, if I have A over B, B cannot equal 0 because I cannot have 0 in the denominator. You cannot divide a number by 0. And we're going to have M be a positive integer, which equals A to the M, B to the M. Let's look at this here. I've got 3 to the power of 7. I'm going to distribute 3 to the 7th. And, I need to use my other color here so it balances. I got 3 to the 7th, 2 to the 7th. If I evaluate further, 3 to the 7th in a calculator is 2,187. 2 to the 7th is 128. If I wanted to divide 2,187 divided by 128, it's approximately 17.09, rounded to the 100th. So, two final rules that allow me to use my exponents in the way that looks best to me. Let's look at these quotient properties specifically, and then in our next video, we're going to put them all together. Simplify the expression completely. So if I look at this, I can see I have the same base in a quotient. That's a quotient of powers property. This is bigger. 4 is bigger than 3. So it is going to go to the numerator. This equals x to the 4 minus 3, which equals x to the power of 1. As a mathematician, I'm not going to write a power of 1. This simply equals x. Alrighty. Now I have 1 over y to the 5th times y to the 3rd, or y cubed. This looks like some fraction multiplication. This is almost like having a whole number. I can put this over a 1 and make it a fraction. And now what I have is I'm going to multiply right across. What's 1 times y cubed? Well, it's y cubed. Anything times 1 is itself. Y to the 5th times 1 is y to the 5th. I don't know why I wrote a 4 there. Goodness gracious. So y to the 5th. I now have a quotient where I have the same base. In this case, my denominator exponent is larger. So I am going to leave a 1 up here in the top because I'm going to move the y down here. And I have y to the 5 minus 3, which equals 1 over y squared. Righty, let's look at this next one. A lot going on. The first thing I've got is 15 divided by 3. I know that equals 5. So 5 is going to be in the numerator. Now I've got x in the numerator and denominator. My 6 is bigger, so I'm going to move that to the denominator. I've got x to the 6 minus 5. Now looking at my y's, I have y to the 7th and y to the 1st, an invisible 1 there. 7 is bigger, so I'm going to move that to my numerator, y to the 7 minus 1. And finally, I have z. I've got an 8 and a 3. 8 is bigger, so I'm going to move that down to the denominator, 8z to the 8 minus 3. And that will simplify to 5. 7 minus 1 is y to the 6 over x to the 6 minus 5 is x to the first power. So x and z to the 8 minus 3 or 5th. And final is going to be that power of a quotient. I know I need to distribute the x squared, the 2 to the x. So x squared and the 2 to the 4, 4 squared, and this equals x squared over 4 squared, which is 16. So that's it for this video and just using those quotient rules on their own. Again, in our next video, we are going to be focused on putting all of the exponent rules together. Thanks so much.